very, very brief introduction from me. My name's Phil Hagger. I've been doing streaming for 12 years. I actually measure it in prime ministers because our first client was Tony Blair. Then we go to Gordon Brown. Then we went to the Coalition who stopped putting video on their websites for a while, but now they're just starting up again at 10 Downing Street. After working in a variety of companies over the years, I've decided that I wanted to go off and explore Africa for a bit earlier on this year. And then when things started happening up in Libya and other countries, I decided that doing deals with Libyan-owned telecommunications companies wasn't the most sensible way to spend my money, and returned back to the industry that I've enjoyed for the last dozen years. My company is Jukwa, and Jukwa is African for platform. It's one of those viewing platforms that you get up on if you want to see big game in Africa. And the reason to choose it, other than it was a 5-letter word and the domain name was still available on the .com, was because I think after 10 plus years in the industry, I've got a reasonable perspective of some of the issues, some of the key players. And my clients are people, broadcasters, corporates that come to me and say, we've got various online video problems and we don't know whether we should choose a Brightcove, a Uyala, a Kaltura. Should we do it in the cloud? Should we do encoding on premises or whatever? So I help them make sensible decisions about what to do. Today on our panel, we've got 3 excellent speakers. We've got Matt, who's the technology evangelist from Amazon. Amazon yesterday was bigged up as the one to watch in our industry. We've got Mark Lawson. Mark's the managing director of Sorensen Media, very famous for making the desktop application Squeeze, but the cloud has impacted their business in a positive way, and Mark will be telling us about that. And then Malcolm from Garland Partners, Malcolm Harland, he's a live digital video specialist and is going to talk to us about some of the sort of case studies of when a hybrid model perhaps might be suitable. Malcolm's very good at, you want to plug things into boxes and do live things, and I'd like to find out how you can plug a VNC into the cloud. So I'm sure we'll hear about that in a minute. Just before Matt comes up and speaks, let me tell you something about each of the panelists and see if you can guess who is who. One of them was employee number 1 at DivX. One of them helped sequence the human genome for the Wellcome Trust. And one of them won an award for spoon bending from Uri Geller. If you last for the next half an hour or so, you'll find out which one's which. Just now you've got to know them a little bit, I thought it would be useful to just get to know you a little bit. Can I ask, just quickly, raise your hands if you're in academic or public sector or charity. And if you're in media, broadcasting, convergence, something or other. And if you're in business or corporates, enterprise. And anybody I've missed out at all? Yeah. Or if you're competitors and selling products in this space or whatever, welcome as well. And those of you more interested in the commercial rather than the technology, could you put your hands up if you're more interested in commercial and more interested in the technology? Hopefully that's the rest of you. Very good. All right, well, with no further ado, Amazon Web Services, please come and take your place. Just start you up for you. I'm sure you're very competent at this.
Okay. So hello everybody, my name is Matt Wood. I am the technology evangelist for Amazon Web Services here in Europe. That means that I get to come to events such as this and talk to smart people such as yourselves. I'm here to answer any questions you have about cloud computing and about Amazon's cloud platform specifically, and also to take any feedback that you have for us and put that back into our roadmap with our product and service teams over in Seattle. So I'm sure a lot of you are familiar with Amazon. We sort of have 3 tiers to our business. So we have the consumer business, which is our e-commerce site. Can you put your hand up, no matter which sector you're in, if you have an Amazon account for buying books and services? That's pretty much everyone. Okay, well, my job here is done, so thank you very much. So we have the consumer business, which is our e-commerce and retail site. We have a seller business, which is an e-commerce platform, everything from running full e-commerce services for the likes of Marks & Spencer's and Target and Samsonite and Timex and all these sort of things, right through to sellers, merchants that want to sell individual items and sell them to our customers that already visit our site. But we also have a third tier of our business, our developer business, Amazon Web Services, what we call web services. A lot of people are calling cloud computing these days. And a question I get reasonably frequently is, what is a book company, what is a bookshop doing running a cloud computing business? And really the story goes back all the way to when Amazon was founded. So Amazon was always built out to be a platform, and we wanted to make our skills and expertise that we built up over a decade or so running e-commerce services on a global scale and allow some of our customers access so they didn't have to go through the same pain points that we did. So we allowed programmatic access to our catalog, to our metadata, to merchants that wanted to sell up on our platform. And we saw a surprising amount of innovation happening. We saw people being able to take our data, take our platform, take our services, and build really innovative new products, unexpectedly innovative new products, to be perfectly honest. And then, probably about 5 years ago, we had a sort of blinding flash of the obvious. In addition to building up all these custom operations and custom procedures and building up this massive global infrastructure to run our e-commerce site, what would happen if we opened that up to the same developers? What if we extended our API access right back to our data centers? Would that drive the same level of innovation? And it absolutely did. This is when we started Amazon Web Services. It's actually now a full subsidiary of Amazon, so it's a separate company from our retail site. This isn't excess capacity left over from Christmas or anything like that. This is a highly operational, well-managed platform that developers and companies of all sizes can take advantage of. So it's really Amazon Web Services I'm going to talk about today, particularly with respect to media, handling media and transcoding, high throughput performance in the cloud. So as I said, we're about 5 years young. We operate a range of different services now, everything from compute to highly available storage to a collection of orchestration and automation techniques, some support services. And just to give you a sense of how things are going, I pulled out some numbers. These are the latest numbers from the number of objects that we store in our S3 service. S3 is our simple storage service. It's a highly available, highly scalable object store. What we call objects are really just files. So these could be photos, this could be user-generated content. This includes a huge number of photos from companies like SmugMug. This includes media for people like Netflix, and I'll talk a little bit about them in a minute. But you can see the growth here. So this is the numbers in billions of objects for Q4 2006, 2007, 2008, 09, 2010, and then the latest numbers, which are Q3 for 2011, where we're currently storing 556 billion objects. Now, I'm no mathematician, but I sort of know exponential growth when I see it, and I don't think we're at the inflection point of this hockey stick curve yet. But 556 billion objects now stored in S3, and they're being served up at a rate of 370,000 transactions per second. So this is a highly scalable platform that's being used by hundreds of thousands of customers across the world. So we see a lot of our customers using this platform, using S3, the simple storage service, and EC2, the Elastic Compute Cloud, for media transcoding and high throughput analytics. And really there's a number of challenges when working with the sort of media, the sort of content that has become common, whether, as I say, it's user-generated content, whether it's 3D content, whether it's movies, photos, whatever. And it really comes down to these four things. The challenge is that typically customers have very, very spiky transcoding needs. They need transcoding and compute infrastructure to manage that transcoding only when they need to do it. They don't need all of that capacity all of the time. And they're very unpredictable content distribution volumes. So if you're using user-generated content or you're building social gaming, web-based gaming, you'll have very unpredictable usage of those games and usage of that content, and often unpredictable generation of that content initially. To house all of this data, if you want to do it in a traditional data center or in a traditional way, it requires a really large upfront investment. So S3 has 11 nines of data durability. It's tolerant to 2 simultaneous points of failure, and building out that level of redundancy and that level of reliability is extremely expensive if you have to build the data center, rack and stack the disks. And building that data center, racking and stacking those disks, powering them, fixing them when they break, and managing them typically isn't the core competency of a media business. It's just undifferentiated work, which doesn't really add much value to the business. And where Amazon Web Services sits in all of this is that we want to take that weight off you. We've got a lot of experience in delivering these services at scale, and so you can use us to take care of the boring, undifferentiated work and focus on what you're actually going to do with the media, distributing that media to your customers. And typically, sort of related to the top one, spiky transcoding needs, often, once you've built these things and you've built out compute infrastructure for large transcoding platforms, you ultimately end up with low utilization for the majority of the time. And so these are disks that aren't spinning, these are servers that aren't serving, but you're still paying for them, and you've still got to fix them when they break. So with the AWS cloud, we try and turn these around a bit. So spiky transcoding needs basically disappears because we have full elastic capacity. So you can use a single server for as long as you like, or you can spin up 5,000 servers and use them for as long as you like. So there's no limits on the amount of infrastructure that you use. So we remove this spiky utilization by having elastic capacity and no upper limits. So you can bring up capacity when you need it and bring it down when you no longer need it. Unpredictable content distribution volumes, well, as I mentioned, we have this highly scalable global infrastructure. We have data centers spread across 5 different regions around the world, and you can take advantage of all of those just as easily as you can a single one. And we move from capital spend, so large upfront investment, to more of an operational model. All of our customers start billing at $0, and you only start paying for storage, for example, when you write the first K of data into our storage service, S3, and you stop paying for S3 when you delete that final K. So you move totally away from this capital expense, which is typically the barrier to entry to new business markets and new products, into this operational market where you can have an idea, spin up only the infrastructure you need to move from dev and test, and finally into a production system at large scale. And because you only pay for what you use, whether it's 1K or one server, you reduce this low utilization problem. You only utilize what you spin up, and you only pay for what you spin up and use. So here's a real graph. This is from a company actually in financial services that were doing some batch processing. And this gives you a sense of the elasticity that I was talking about. So this is the number of the Elastic Compute Cloud instances, what you would typically call a server, we call an instance. And they move from 300, their steady operational state, and they can burst up to 3,000. And we see exactly the same case with people working with media. When you want to do transcoding, you typically want to do it when the data is there, when new sets become available, and then you can spin up additional infrastructure, and you only pay for it when you're using it. The rest of the time, you can just scale back down to your steady state, which maybe powers your website or your normal transcoding pipelines, and stay there. Netflix is a big customer of ours. They're moving to be run entirely on the Amazon Web Services platform. I'm missing some text here. But basically it says that Netflix had a transcoding problem. Netflix obviously deliver a lot of content, but they had a transcoding problem when the PlayStation 3 launched. They had a huge amount of data, tens of terabytes of data that they needed to transcode for the PS3 launch. And so rather than having to build out that capacity at short notice ready for the launch, they're able actually just to spin up, I think, 1,200 additional instances to run their transcoding pipeline, and they had all of their content transcoded and available on day one. And because with this elastic on-demand model, basically running one instance for 100 hours costs the same as running 100 instances for 1 hour. So you can get a lot of work done, and you get to choose the balance for where the sweet spot is for your business. This is the Netflix usage graph. So you can see this is from summer 2010. Thank you to Netflix for allowing me to show this information to you today. Production values are much, much higher now, and I apologize that this is maybe a little bit woolly around the edges. So this covers several months along the bottom and many thousands of EC2 instances. But you can see here how spiky content encoding usage is. It goes all the way down to 0, and it can go up and up and up. Now, in a traditionally provisioned infrastructure, you'd have to provision for the maximum utilization. So this peak over on the right-hand side, you typically over-provision by 10 or 15% based on your peak utilization, and you can see just how much capacity you'll be wasting. Everything between basically the top of the graph and the red line would just be wasted money. This is money that you would have spent that you wouldn't be able to use. And you can see some of their other uses, test and production, and they do some log analysis up on EC2 as well. Sorensen, I won't talk in too much depth about this. Sorensen Media run their Sorensen 360 service. This is transcoding as a service, and basically makes use of the full Amazon platform, everything from EC2 for the transcoding and application servers. They run the databases, storage on S3, and then use our CloudFront content distribution network to push those videos back to the user. Similarly, Zencoder, a hosted transcoding service, doing all the transcoding up on EC2. And it's very easy to build out these sort of platforms because this API, web service-driven approach allows you to integrate your pipeline, integrate your existing tools and your existing transcoding services right up into custom tools, which you can ultimately perhaps sell on to other customers. We're seeing a lot of usage with 3D, so we run different instance sizes. So this is the physical hardware that your software can run on. And at the top end, that includes general purpose GPUs. They're NVIDIA Teslas. You get 2 of those, so you get about 800 GPU cores, great for transcoding. And we see people building out all sorts of weird and wonderful encoding platforms, including full Maya rendering farms. And there's some great videos about how to set this up at this web address. And these slides will be available after the talk. So that's some of the use cases. That's some of how elasticity plays towards rendering and managing media in the cloud. We also have some pricing changes that are sort of unique to the Amazon way of doing things. We've reduced our prices, I think 15 times since we launched our services without any real competitive need. And that is something that we have definitely inherited from our cousins in retail. We want to reduce our costs as low as possible. And the way we do that is basically through economies of scale and by delivering different pricing levels for different use cases. So we have on-demand pricing. That's the price that you pay if you just go up onto our website and start requesting these services. You can log in with your existing Amazon credentials as long as there's a credit card attached. If you know the sort of capacity you're going to need ahead of time, you can use reserved capacity, and we offer that for things like EC2 and also for object storage and object delivery. But we also uniquely, we have spot pricing. So with this, we take a look at our own excess capacity each and every hour, and we recompute the value of that based on its availability. So you basically get to bid against this spot price, this spot market. So you can set a bid price, which is the price you're willing to pay for your compute, for your transcoding. When the spot price drops beneath your bid price, we'll make that infrastructure available to you. The deal being that if the spot price goes above your bid price, we'll take it back again. So you do need to architect for the fact that interruption can occur, but this is an extremely cost-effective way of delivering huge amounts of compute, and it's really built for the sort of batch processing workflows that are commonly found in media transcoding. So this is what it looks like. So we have an API where you can pull out the historic values, and you can see it there fluctuating around. This is for a large CPU instance running Linux. You can see the variability there, and you can see where you could set your bid price. And you can get a huge amount of compute available. So these 2 slides are also blank, but they basically say that cycle computing using the spot market, we're able to spin up 30-odd thousand cores. For that, we charge them just $1,200 an hour. So you can spin up a remarkable amount of compute and pay a really small amount for when you need it. And as I say, the flip side to all of this is once you've generated the data, you need to get it out there. So we have our own content delivery network. We've got 21 points of presence around the world, Europe, America, South America, over in Asia Pacific. It's called CloudFront. You can read more about it. This supports video on demand and live streaming with Flash Media Server. It's also got policy-based authentication, so you can limit the availability by time of day or by IP address or named account and all that sort of thing. And so once you've generated, transcoded your content, you can actually get it out and do some edge caching with the Amazon CDN CloudFront. And we were very lucky to win an award yesterday for the Reader's Choice for content delivery. So thank you to everybody who voted for us for that. So if you want to read more about this, there's more available on our website at aws.amazon.com. And that is a very quick overview. I'm happy to answer questions, but you can also drop me an email on matthew@amazon.com. Thanks a lot.
Thank you. Well, that's not on, so I'll go over here. If we just save the questions until at the end, if that's okay. Mark, if you want to come over. Matt, that was amazing. I sat through 4 or 5 hours of you doing that a couple of weeks ago, and I got so much out of it, but to cover all of that in just 10 minutes was phenomenal. Thank you. Well, I'm absolutely sure you can work PowerPoint, but I thought, well, I'll just do that for you.
Thanks, Phil. Hi, everybody, and thanks for coming along to the last presentation of the show for the week. I've only got 150 slides, so we should be here till about 8:30 this evening. At least somebody's paying attention. So we're from well done. So Sorensen Media, as Phil mentioned before, we've renowned more for our years in the desktop encoding marketplace, and in fact yesterday we won an award for the best transcoding product here. And again, great thanks to all the readers and our users who voted for that. So it's always great to get awards from from users as opposed to anywhere else. So as Matt was saying, video and what's driving the increase in video encoding, there's a lot going on and even more on a daily basis as we get together at these kind of events. And here's a map you've probably seen before, which talks about the increase, particularly in mobile, very much now with smartphones and iPads, etc. People are consuming, so much more video. And what that's doing, of course, is driving the need to encode more and more pieces of content. So we've got stuff for mobile tablets, even televisions, of course, obviously smart TVs these days as well. So it wasn't too long back, I think we were all believing that there might actually be a one video standard that we could all drive towards and deliver our content with, but actually it's getting worse. Each time a new device comes out, there seems to be a new format or a new definition, and all that's doing is actually increasing the workload on the encode. Every time people have to make content, they have to make it in many more renditions. And I think from Matt's presentation, he talked about Netflix, and some information I was talking to one of their guys about the other day was for every single movie they have on their infrastructure available to customers, they make over 100 renditions of each copy of every video. So that's all the different formats and devices that they cope with. So that's pretty enormous, and that's one of the reasons why there is so much encoding going on right now. And of course, we've heard a lot this week as well about over-the-top consumption. Lots of broadcasters are looking for alternative ways to make their content available, again, on the IP market with mobile laptops, etc. And of course, again, something else this week we've heard a lot about, adaptive bitrate. It's a fantastically efficient way to allow users to get the best experience, even though they might be in a poor coverage area, in a weak Wi-Fi area or 3G area or whatever. So we've got adaptive bitrate now, but what that does mean is that each time we might have 6, 8, 10 different renditions or bit rates within each video. It means we have to actually encode each one of those particular pieces. So again, that's adding to the requirements to encode. So there is now a debate, as we've all heard, like some of our friends at Amazon, with cloud services, and customers now have some choice to make in terms of encoding their video. And as Matt alluded to before, it's a difficult choice when you've got to invest in potentially quite a lot of hardware to do your own encoding, or do you do it in the cloud? Whereby you've got less in terms of capex and potential scalability. Well, it really is all down to customer choice at the end of the day, and how does your particular operation fit into any given scenario. So here we have a little graph which basically, as you see from the pink line there, that's the actual demand of your video encoding. But in order to cope with that on your on-premise situation, you perhaps have something like the blue line here, which is your capital investment in servers and software, etc. And at any time, it's quite difficult to forecast that, particularly encoding when you've got lots of bursty requirements. So you might actually get the pink area here where you've actually not got enough server capacity to meet the demand. Or in fact, on the left-hand side of the graph, you're missing a lot of opportunity for yourselves where you've paid out a lot of money for servers that actually are being underutilized. So that's always the classic sort of situation with trying to run your own on-premise stuff. So with pros with on-premise, very much you have complete control over your own hardware. You don't have the issues of trying to get content off of your network necessarily into the cloud, in particular in this particular scenario we're talking about. So there's no bandwidth requirements there. But in terms of cons, it very much is a fixed capacity. It has to be managed. You have to invest in people and time to manage that. You've got to obviously buy the equipment and software to go with it, and all the support that goes along with that. It's not just human beings to support the technology. It's air conditioning, it's real estate, rooms, electricity, etc. That goes along with running your own equipment. So in terms of cloud, here we go with some pros and cons for cloud. It is very much on demand. It's there, and you just get what you need. It's virtually unlimited in scale. Literally tens of thousands of servers can be spun up pretty quickly. Very minimal in terms of IT requirement. The sort of support and the building of that scalability is not in your domain anymore as a user, It's very much in the provider's domain. And it now becomes an operating expense as opposed to a CapEx. But the big cons in terms of running something in the cloud, you have got to cope with that data transfer. And in particular in our industry, in video, some of those files are pretty big. So transferring that across and into the cloud is a challenge, and that's something that we all have to work with. Hardware configurations tend to be pretty much predefined in the cloud, so whatever we have there is what it is, and you can't tweak it necessarily like you might do your own stuff on premise. And again, there's the bandwidth of upload. But you do kind of get this kind of scenario with the cloud. So very much the pink line is the actual demand, and the provisioning of the servers very much follows that. Always stays slightly ahead of the game. It's there. It's pretty much instantaneous. The beauty of that, of course, is that when you don't need to do anything, if your demand actually goes down, then so do your servers. So you don't actually end up paying for things when you don't need to use them. We use this as a how do we get more than 24 hours in a day in terms of video encoding? If you sat with one server and you're cranking through a number of videos, it obviously just, typically with high definition stuff these days, it might take 3 times real time to actually encode that video. But if you desperately need to get that done quicker, then with the cloud scenario, you just literally throw servers at it. You can have many thousands of servers in the cloud in order to accomplish your tasks even ahead of time. So if you've got a library of content that you need to encode, and you've got to do it as soon as possible because your launch is going to be the following week, you can literally do that within the cloud because you can scale so many servers up to handle that task. So we have a product called Squeeze Server. What is it? Well, it's effectively it's a high volume automated professional encoding server platform. It's essentially based, or the algorithms for encoding are based on our very successful and very long-standing Squeeze engine, which was in the desktop product, or is in the desktop product. But the code around that is built around actually maximizing the efficiencies of a server environment. So it's multi-threading, memories, disk drives, network connections, etc. So it just maximizes the encoding performance in a given environment. And we also have things like API. The API is very, very important for people to be able to integrate this kind of software into workflows. Very rare when we just deploy a server as a piece of vanilla software. There's always a lot of integration goes on with most customers because everybody wants to use it in a different way. So having a very full and easy to use API is really important for that. As also is the database that goes along with that. Running multiple servers, you're always going to need a database to find out, to set the requirements of any jobs that you have, of the queue priorities, etc. And of course, archiving of jobs as you go forward. You're going to need to know what's been completed, what's done, where's it gone, etc., etc. So database is all integrated part of what Squeeze Server is. Our Squeeze Server product, you can use on-premise. It works on a Windows operating system, Windows Server operating system as a platform. But exactly the same software resides in our cloud-based service. So it's exactly the same server software. And if we had to provide you with a cloud-based service, it would be based on AWS cloud infrastructure. But it's exactly the same software. And as you can see here from the workflow, as you go through it, you notice where the source download here, we've got Amazon S3 as a bucket, as we call it, as a place to ingest your content from. You can have it from anywhere locally on your LAN, from an FTP site, etc., or indeed other cloud services you might have content stored. And the same at the end where you go to upload. When we finish the transcode, you can drop content to any of these particular storage places on your own LAN, in the cloud, even directly to a CDN. We deliver to most of the CDNs, or the common CDN players anyway. You can actually publish content directly from the server into CDN networks. We even do it into CloudFront with our own 360 servers. So in terms of encoding in the cloud, it's not just about encoding as such, and we've heard about some of the other challenges here. And we partner with a couple of other guys with our cloud-based services. First one, namely, being a company called Aspira. And they help us get over the dilemma, and they help our customers get over the dilemma of how do you quickly get your content into the cloud, and how do you get over that bandwidth issue. Aspira, a very, very successful company in utilizing technologies to maximize the transfer of data up whatever internet pipe you happen to have. If you've got a 2 meg pipe into the internet, then using Aspira as a technology, you can get up to 95% efficiency on that 2 meg pipe. So it's very, very efficient, as opposed to using sort of HTTP, FTP type protocols where you might be 35 to 40% efficient. So it's a massive increase in terms of the throughput into the cloud. So we use partners like Aspira to do that part of the equation. But also we use a partner called RightScale. This allows us to set particular business rules for our clients. When clients set those business rules, i.e. how they want that cloud-based solution to scale. Obviously, if you scale 5,000 servers up in 10 minutes, which is quite possible, and very, very, very doable within the Amazon environment and using RightScale to control it, you want to be aware of how much the cost is going to be to do that and make sure that it fits to your business model. So if you've got a mass encoding job to do and it's justified in terms of cost and you've worked out the metrics, then literally the RightScale tools will allow you to scale in accordance with your particular business plan and requirements. But it's not just about either or in terms of on-premise or in the cloud. Because our software is the same whether it's on your premise or in the cloud, we have the ability to extend that to what we call a hybrid system. So you might decide that your day-to-day usage is you're quite happy to run that on some servers in your own establishment and have control of that in the normal way. That's all fine. But hey, what happens when you get the requirement to re-encode the whole library into the latest iPad 3 format or something like that? And that's where you've got a huge demand. You've got to do it very quickly. Well, you can overflow and spill those burst requirements into the cloud. That's exactly what the combination with our partners like Aspira and RightScale and Amazon do. It scales extremely quickly, and you can have many hundreds of servers powered up to cope with that burst requirement. And then once that's completed, it all shuts down. You don't incur the costs, and you just sit back on your on-premise environment. We have within Sorensen as well, because we've done a lot of work in the cloud, and we've worked with our friends at Amazon for, 3 years or more now, I think, Matt. We're very early into the cloud market with video encoding. We've developed a whole bunch of what we call reference apps, which are aligned on a lot of the popular devices like iDevices, Android devices, and that's developed code that allows people to upload content directly from those devices into our cloud-based encoding solutions. It's been quite important to people to be able to do that for lots of different reasons and lots of different applications, and we have a lot of reference apps that we use to do exactly that, including also deploying technologies from our other partners like Aspira, because we can reuse their technology in the mobile area in order to get extremely fast or certainly more efficient uploads from mobile devices. Quick word about, everybody always mentions security typically in the cloud. I wanted to cover that one off a little bit here. This is a project we had with a company called Technicolor, who I'm sure you'll all know. They offer what they call a digital dailies solution. It's called ShareView. They offer it to the film studios and filming companies who basically, at the end of each day's shoot, they'll upload a load of content into the cloud. We do all the transcoding, and we send it out to iDevices, iPads, iPhones, PCs, etc., so that the execs and directors can view overnight. They can comment in the time frame and pass comment whether they want certain scenes reshooting or whatever. Pops it all back up, and off they go. So the director the following day can see what he needs to do, if he needs to reshoot or whatever. The reason I bring that up as a case study, it's obviously quite a nice case study from our point of view, but also security-wise, you probably won't get any more valuable content than that. A daily shoot of, whatever the latest fashionable topic is in the UK at the moment. It might be spooks, for instance. You do not want that getting out into the wrong hands at all. And so this system that we built for Technicolor passes all those security requirements. We built all that in terms of the encryption, right down to the devices as well. So yeah, that's an example of how we sort of cope with security in the cloud. And I know that Matt can talk to you about lots of things that Amazon are doing about secure environments as well. So, and that's pretty much it from me. Thank you.
Okay, thanks very much. We'll move swiftly on to Malcolm. Your slides just follow this one directly. Very good.
It's not that I'm ready to go straight away, but it's a prop nevertheless. I'll trust this is going to work.
Next slide.
No.
That's his last one.
One more. Anything else?
Yes, next slide.
Okay, so I will wrap up the presentations today. As Phil said, thanks for you guys for all staying and staying with us. My name is Malcolm Harland. I'm a director of Garland Partners Limited, and we are specialists in primarily live video encoding, and perhaps putting a different perspective on what Mark and Matt have said from a cloud-based process, to maybe trying to get you to think about your own live workflows and how that shift from a physical piece of hardware doing absolutely everything to something which is more related to a physical piece of hardware doing the early stage, and then perhaps moving more through into a cloud-based scenario to give yourselves the things that the guys have talked about already in terms of scalability, early uptime capability, overflow capability, as well as reformatting into different methods of delivery. So a little bit of background from our side. We've been around for 8 years, which we don't think is for very long, but you guys have said you've been around for less than that, so I'm really pleased about that. And we really look to provide innovative solutions. We work with a range of partners. We have a very knowledgeable team here in the UK, and we cover all the different markets from education through corporate and enterprise and to global broadcasters. And working with industry partners, we cover that whole cross-section, and primarily are in business to help guys like yourselves to deliver live video to 3-screen platforms. Just a little bit about who we work with, just to cover off the 3 different case studies that I want to mention. Inlet Technologies, now part of Cisco, very powerful hardware-based encoders which deliver themselves to 3-screen, including to 3 different types of mobile platform directly from that platform out to servers. Viewcast Corporation, anyone who's been involved in video encoding for any length of time will know Viewcast, from capture cards all the way through to a very strong range of appliances. We work with vBrick Technologies and TerraQ, who specialize in that enterprise video market, education, government, healthcare. Those markets used to be locked down. People used to deliver video purely within premises, purely on their networks, and now there's a need for that video to be shared globally, whether it's to their audiences, to their staff, to their clients. We have LiveU, and for those not familiar with LiveU, this actually delivers very high broadcast quality video over 3G cellular networks. And it can deliver it from pretty well anywhere in the world to anywhere where you've got a downlink server. Alternatively, as I'll talk about later, it can deliver anywhere in the cloud where we may have an Amazon-based server that can then deliver on to endpoints. And at the entry level of the market, we have a new company working with us here at the show called Stream Appliance, who have a very low-cost encoder. It's enabling people to try to get their content and their services live out to their audience in either flash format or using cloud-based transcoding into any mobile format to any device. And there is a pressure to do that. We've talked about low capex already, trying to make things on an OpEx basis. And as a hardware vendor, that's something that we're trying to help our clients do more and more, because it's very expensive to try and get high quality video out purely on a hardware-based platform. Just a few things that we need to think about when we're talking to our clients. You know, in the end, we're actually in a very, very good position, because however much takes place ultimately in the cloud, something has to happen on a piece of hardware to encode, to prepare it for delivery into the cloud, whether that's for on-demand services or for live services. And it often is the most critical point of failure. You have to think about what you want to encode and how you want to get that seen by your audience. There's a need to consider the endpoint. We've talked about PC or Mac delivery, mobile devices, OTT services, direct to TV. But also there's a need to consider the delivery network. Are you delivering to web? Are you delivering to cellular, corporate, educational networks? And that may well determine how you decide to move your content and how to repurpose your content, whether you can do it all outside of the cloud, or you are starting to use hybrid services where you're delivering some content through a more hardware-based infrastructure and then moving content out through a cloud-based infrastructure because it's going to give you greater reach and greater scalability. Just some thoughts on some examples which we've worked on a lot over the last 2 to 3 years. We're seeing more and more demand. For example, universities need to get their graduation ceremonies out as far as possible. I don't think it's only a UK phenomenon that we have lots of international students. Their families and friends cannot see their graduation ceremonies. And how do they want to deliver those? And where do they need it to go? We've worked with 2 universities in the last 3 months who have had 20,000 simultaneous views of their graduation ceremonies over a 1-week period. And they have the need to be able to deliver locally and through a piece of hardware, and simultaneously to be able to get that up into the cloud, to be able to get it transcoded into a mobile format, for example, or multiple bitrate formats to be able to hit all of those different connection points that you may get worldwide. You know, we have a very good situation here in the UK where many people have got access to broadband, but in other parts of the world, maybe they only have 512k of broadband or even 256k. You don't want to be sending out one single bitrate feed, but equally you don't necessarily want to be sending 4 different bit rates, all from your premises, all chewing up bandwidth. Needs to deliver to large screens, you would do that locally, but equally you can still deliver to large screens on another campus in another part of the world. Many universities have dual campuses, China and UK, Malaysia and the UK, for example. And equally, you may want to deliver to PCs on the network without flooding your own network. And by having network-based delivery, rather than pulling everything back down from the cloud where you're going to flood your own network, that hybrid approach works extremely well. I mentioned LiveU already. LiveU is a bonded 3G mobile contribution system. It uses 7 3G data channels simultaneously to deliver very high quality, highly secure, really robust and resilient video for broadcasters, news gatherers, sports portals, event-based companies. There are certain requirements that this unit has to have. One of them is connectivity on its downlink, because it needs to be able to deliver 3 to 4 megabits per second of data into a downlink server. Until recently, all of those downlink servers that we've operated worldwide have been physical servers in a location. We now have Amazon-based LiveU servers which are able to take the feed, repurpose that feed, and push it out to whatever audience is required. And that makes it a very quick, very easy way to deliver. It also means you're only paying for those services when you actually need those services. And LiveU is a lease model. The Amazon cloud-based is effectively a lease model, so you have almost zero capex. And suddenly you can become a news broadcaster or an event broadcaster and do the thing that you're good at as an organization without a huge capital expenditure, and you're only paying for the services that you use. Finally, broadcast simulcast. As a company, we've been heavily involved with the main broadcasters here in the UK to help them do their simulcast capability. Multi-platform delivery is imperative, of course. They want you to see their content, so they get advertising revenue wherever you are, whenever you want to watch. For redundancy, we've talked about Matt and Mark have both talked about the need for redundancy and resilience and scalability for key programming. High flexibility, I think, also is really important. If you are only going to focus on a single piece of hardware, you have to be aware that that single piece of hardware will become more and more redundant as time goes by. So think about the ability to have a single piece of hardware that you can see on the foreseeable future. How good is that piece of hardware going to be? Make sure it has the ability to push something extra into a cloud-based transcoding service so that you will get more value from that capital expenditure that you put in the first place. And that security of tenure, I think, is also a very important point for anyone in that broadcast, simulcast area. You have to be able to rely on the partners that you're working with in a cloud-based environment. And clearly from an Amazon and a Sorensen perspective, that history of capability and durability is really important. It doesn't necessarily mean to say that's always going to be the case for a cloud-based service which comes and may go shortly later. So I think from a perspective of a hardware vendor, we embrace the cloud-based approach because it actually gives a far greater opportunity for live broadcast, live web delivery, mobile delivery, for continuous services like a simulcast, or ad hoc events where you may run one specialist event every month. You may be a religious television channel, a community channel, an organizer of an event like this. You don't want to be paying for services that you're not using on a day-to-day basis. So hopefully that's given some background from our side as a hardware vendor as to how we feel that the coming together of cloud-based services, utilizing physical hardware based on a premise where you cannot, Phil, unfortunately, get the BNC cable into the cloud just yet. But you have to find a way to be able to bring those two together. Okay,
thank you very much. And that was an award-winning box,
that
was it?
was an award-winning box. It got the Streaming Media 2011 Reader's Choice Award. Thank you for that prompt.
Okay, very good. So where else? Certainly not next door, but where else would you get 3 award winners in one panel? And now you can take advantage for the next quarter of an hour. If you need to ask any questions of the experts, please do raise your hands. I've got a few, but I don't want to swamp it. Glyn.
The actual title of this bill is in-house or in the cloud.
Yeah.
Obviously, Amazon Web Services are talking about cloud for obvious reasons. That's all they are. But there's no mention of in-house here. The broadcasters are still saying quality, this content is my brand. And they're religious about quality control in their content. So can the in-cloud services truly offer that quality that putting a physical box in a physical rack can do?
Well, I'm not going to answer that, although I have my views, but certainly, Mark, I'm sure you'll have a comment on that. Well, I'll give them after we've heard from the experts.
Is that one on? Yeah, absolutely the right question from our point of view. And that's why I think there was a little piece about on-premise in my presentation, given that our solution is the same core encoding engine in the on-prem solution as it is within the cloud. So in terms of delivering quality, and you'll probably be aware of Squeeze, we've won many awards for the quality aspect of our video encoding. It's exactly the same quality that's in terms of the engine that's used within the cloud. So you would not get anything different. Obviously, you don't have the hands-on control as an individual user. And the bigger, wider debate about whether you want to, have control of the equipment, and there's a whole cost and a business case analysis to run through with that, which we gladly help people discuss and work out the best ways around it. I think most of our customers are seeing that there's such a massive increase in demand that retaining everything on-prem is becoming more and more difficult for people.
There's a very strong financial argument as well, isn't there? I mean, that was made clear by what was presented by certainly the first 2 panellists. But my personal view is that it gets a little bit political in that the broadcasters that for many, many years, and myself as a broadcast engineer, we like gadgets. We like things with LEDs that flash on and off. We like to see them humming and running, and we like to show people around and say, I understand how this rack of 100 servers works. I understand how this works. There's also the issue that it could be your job, that if you say, let's farm it out to the cloud, you might then not have a job in a few months' time. So I think there are vested interests, but as Mark said, if it's the same encoding algorithm, shouldn't it be the same quality at the end? Yes?
That might be the case for VOD, line content. It doesn't really matter how, if it's 1 second, 2 second delay, it's the same quality. But for live, there's very sensitive for the delay. Like if you're kicking up 1,000 of those instances, what is the delay in case of live content?
So let's just make sure that I've understood the question correctly. You're doing a live webcast, and...
Do a live webcast, and I want to do the transcoding in the cloud.
Right. And so what you might hypothetically want to do is fire up half a dozen Wowzer servers to, just for the duration of the broadcast, convert them into lots of different formats. Is that roughly what you were suggesting?
Yeah.
So okay, my answer to that would be, and I'm not sure if it is my role, but I will hand over to the experts again. But if you know you're going to do a live broadcast, then you do know in advance. So even if it does take 5 or 10 minutes to set them up, maybe you just turn them on a little bit early, but maybe that's too simple and I haven't understand the nuances. Do the panel have a comment on that?
I would say it's a great question, because where you have that for live especially, where you have that encoding capability in-house, you can easily measure and predict the latency to multi-screen delivery. And for sure, if you push into a cloud-based platform, you will add some latency into that. And I think the question then is whether you as an operator and an owner of that content are comfortable that there is a slightly longer delay for viewing those pictures from a cloud transcoded process compared to producing, for example, all of your content from a single hardware platform. The only thing I would probably come back on that is that now there is an expectation from the viewer. Whether that expectation is one that's preferred and accepted, there is an expectation that if you're viewing something on an iPad, it will be so many seconds later than viewing it on the web, which is equally so many seconds later than viewing a simulcast on TV. And I think the additional delays of moving through to a cloud-based service would probably not distract too much from that already spread of maybe anything up to 30 seconds between a live TV simulcast and something coming out on an iPad.
So did that answer your question? Did I misunderstand it? It isn't the latency of starting up the encoding engines, it's the extra delay to go to the cloud for transcoding.
In my case, we have the satellite box, and we have transcoding boxes. Like for HTTP live streaming, we're chiming it up. We can transcode each segment in-house. But let's say for transcoding those segments in the cloud, there is some latency uploading the segment, and when can we expect to have that transcoded? If it's 1 second late, 10 second late, or it might be buffering state of the clients.
Yep.
You can't get any guaranteed delay.
So maybe it really is very, very difficult to come up with a general rule about whether you should do it in the house or whether you should do it in the cloud. Or, I mean, my takeaway from the panel today is that it's not either or, but it's a hybrid model, and you have to tune, with the help of experts, you have to tune that hybrid model to say what can you put into the cloud for what reason, and what do you need to keep back in the premise. So any other questions? Yes, at the front, please. So is the question, is it possible to transcode VOD on demand? In other words, does that mean you just keep one copy, one source file, and when someone asks for it, you transcode it for them? Is that the question? Okay, any answers?
But there may well be. I think Obviously, in the live scenario, that's a little bit different. I think we've seen a few times this week that there are different solutions in live to enable that sort of one-to-many scenario. Certainly from a VOD perspective at the moment, the way to do it is to encode for each format that you've got. So iPad 3 arrives, you've got to re-encode your library at the moment. It seems to be the way it is for VOD as we speak.
Okay, gents, thanks. Okay, a couple more questions from the floor before we do wrap up. Hands up if you have one. Okay, because I've just got one or two last ones. Matt, the issue of uploading content seems to come up a lot. Mark talked about a sparer. That's an accelerated way to get files to you. Do people like Netflix just upload gazillions of files to you, or do you have a better way of accepting incoming files?
So there's a number of different ways of getting content up into the cloud. So you can upload them directly over your connection, and for a certain, if you have just a single or a limited number of source files, that can actually be quite effective. We have really, really large pipes into our data centers, so it's usually your local connection, which is going to be the rate limiting step. Some customers might make use of our import-export service, where they just stick their content onto source content onto a USB hard drive, and then they can ship that to us, and we'll just load it in. So we'll have an engineer plug it in for you and load it into S3, and then we're pretty good at shipping things around the world, so we'll send the disk back to you at the end of it. But we also have something called Direct Connect, which allows you to create 1 gig and 10 gig dedicated fiber directly into our data centers. And so that's what a lot of people do. They take existing on-premise or co-located facilities, and then on demand you can spin up with an hourly rate 1 gig and 10 gig dedicated fiber direct into our data centers. And so that's dedicated private bandwidth just for your usage, and that'll go directly into your EC2 server. So if you are loading a lot of data in that way, that's a very, very good way. But likewise, accelerators like Aspera are a very good way of getting it up there. And also recently we removed all inbound bandwidth charges. So it doesn't cost you anything in terms of bandwidth prices to get it up there initially. So yeah, import, export, upload, and direct connect can help get it up there. In addition to that, Direct Connect works very well with the sort of what we call virtual private clouds, where you may have a private subnet, which may be on-premise, which may be your sort of baseline capacity. Then you can spin up additional capacity in a completely isolated, network-isolated environment in an elastic infrastructure. Extend your existing IPsec virtual private networks, create public and private subnets up on EC2, and you can also house dedicated instances, so you can be sure that you're the only person running on the actual physical hardware, and then you get all the advantages of choosing the size of the hardware, adding more memory, adding more CPU, and having the elastic advantage, but still having your baseline at-rest capacity on-premise, and that works very well with this Direct Connect facility as well.
Thank you very much. I mentioned at the beginning, just a few weeks ago, I went to a presentation by Werner Vogel, who's the CTO of Amazon Web Services. I was absolutely amazed by the breadth that Amazon do. And I went home and, being a bit geeky, fired up some servers. The documentation is great online. Matt's very approachable. At least he was very receptive to some of my questions. And I would encourage you just to have a play with it. I think you'll be quite surprised at what you can do. And Mark, is there any image Sorensen squeeze or anything like that that people can play with if they want to, or do they have to buy something first before they can just experiment?
Well, we have some pretty basic, simple to access transcoding products in the cloud that it's not huge amounts of money to actually try. We do for all our any clients that we're talking to that specifically need to test against a set of plan or schedule or whatever. We'll do that together in ascertaining the right configurations, etc. So that's no issue to us. But in general, if you just want to go just via our website, you can pretty much spin up your own cloud transcoding service and start straight away. And it won't be too long into the future before we're trying to simplify that even more to allow people to get really, really low cost entry to doing exactly what Phil suggests, which is just having a play with it, because it's one of the best ways we've seen of people actually beginning to understand it and getting used to what the cloud can do for you. And so the easier we can make that for people, the better it is, usually all around for everybody. So.
Good. Well, Malcolm, do you have any parting words, or shall we wrap it up there?
No, I think apart from hopefully there's a very sort of good consensus that hybrid approach is developing very well, I think, for live and on demand.
Okay. Well, thank you very much, gents. Just as we said at the very beginning, there were 3 interesting facts. Let's just find out who was employee number 1 at DivX. Put your hand up. Mark. Who helped sequence the human genome? So that means Uri Geller's award-winning spoon bender was Malcolm. You knew it all along, didn't you? Thanks so much for coming. I hope you've enjoyed the conference this year. A round of applause, please, for our panelists. And I hope to see you all next year, and travel safely.
Thanks, Phil.
Good stuff.
Yes. Thanks very much. Don't forget USB sticks.
I won't. Thank you.
Appreciate that. Thank you.